What is K-means clustering and how does it work? K-means is an unsupervised learning algorithm used to divide data into groups or clusters. It works by selecting K initial centroids and assigning each data point to the nearest centroid. Then, Hugging Face spaces that can it updates the centroids based on the mean of the points assigned to each cluster, repeating until convergence. How do you determine the number of clusters nk in K-means? The number of clusters NCK can be determined using methods like the elbow method, where you plot the sum of squared errors SSE against different K values and look for the elbow, where the rate of decrease in SSE slows down. What is the objective function of K-means? The objective of K-means is to minimize the within cluster sum of squares WCSS, or the total distance between each point and its assigned centroid. The algorithm tries to find K centers that minimize this distance. What are the main assumptions of the K-means algorithm? K-means assumes that clusters are spherical, equally sized, and have similar densities. It also assumes that each data point belongs to exactly one cluster and that the number of clusters K is known beforehand. How does K-means handle large data sets? K-means can handle large data sets, but its computational complexity increases with the number of points and clusters. It can be sped up using techniques like mini-batch K-means, which updates centroids using a subset of the data. What are the advantages of K-means over other clustering algorithms? K-means is simple, fast, and works well with spherical clusters. It is also scalable to large datasets and computationally efficient, especially with well-separated clusters. What are some limitations of K-means clustering? The K-means struggles with non-spherical clusters, varying cluster sizes, and sensitive to initial centroid placement. Clusters that can, it also requires the number of clusters K to be known in advance and doesn't handle outliers well. How does K-means handle outliers? K-means is sensitive to outliers because they can disproportionately affect the position of centroids. Outliers can be managed by removing them or using alternative clustering methods like K-medoids or DBSCAN, which are less affected by outliers. What is the role of the centroid in K-means clustering? Centroids enter the center of each cluster and are used to assign points to clusters. The algorithm updates centroids based on the mean of the points assigned to them, aiming to minimize the distance between points and centroids. How does the K-means algorithm converge? K-means converges when the centroids no longer change significantly between iterations. After each iteration, centroids are updated and the process repeats until the assignment of points to cluster stabilizes. What are the differences between K-means and K-medoids? Both algorithms aim to partition data into K clusters, but K-medoids uses actual data points as centroids, while K-means uses the mean of assigned points. To get K-medoids is more robust to outliers because it doesn't rely on averaging points. What is the role of Euclidean distance in K-means? Euclidean distance is used to calculate the distance between each data point and the centroids. The algorithm assigns points to the nearest centroid based on this distance, which is key to defining clusters. How do you interpret the results of a K-means clustering algorithm? The result of K-means gives K clusters each represented by a centroid. You can interpret the clusters by looking at the points with them and analyzing common features. Visualization methods like scatter plots can also help understand the clusters. What are the main steps involved in running K-means clustering? The main steps are randomly initialize K-centroids, assign each data point to the nearest centroid, recalculate centroids based on the assigned points. Repeat steps 2 and 3 until centroids no longer change. How do you deal with categorical data in K-means clustering? K-means typically works with numerical data. For categorical data, you can use methods like one-hot encoding to convert categories into numerical values, or use alternatives like K-medoids that handle categorical variables better. What happens if you choose an inappropriate value for K in K-means? Choosing an incorrect K can lead to poor clustering. If K is too small, clusters may be too broad. If K is too large, clusters may be too specific. The elbow method can help find a reasonable K value. How does the initialization of centroids affect K-means clustering? The K-means is sensitive to initial centroid placement. Poor initialization can lead to suboptimal clustering or local minima. Methods like K-means help select initial centroids more effectively to improve the results. What is the elbow method and how does it help determine the optimal K? The elbow method involves plotting the sum of squared errors. S is equal for different K values. The optimal K corresponds to the elbow, where the SE begins to decrease at a slower rate, indicating that adding more clusters doesn't significantly improve the model. How do you handle missing values in K-means clustering? Missing values can be handled by imputing them the mean or mode of the feature or by removing rows with missing values. Alternatively, eigenface spaces like K-medoids can sometimes handle missing values more effectively. Can K-means be used for non-spherical clusters? K-means struggles with non-spherical clusters because it assumes that clusters are roughly circular or spherical. For non-spherical clusters, algorithms like DBSCAN or Gaussian mixture models might perform better. How would you assess the quality of a K-means clustering solution? The quality of K-means can be assessed using metrics like Silhouette score, Dunn index, or within cluster sum of squares (WCSS), ping faces that can. These measure how well separated the clusters are and how compact they are internally. Huggins space again, what is the difference between K-means and hierarchical clustering? So K-means requires the number of clusters to be specified in advance, while hierarchical clustering builds a tree of clusters and does not need the number of clusters to be known. Hierarchy phases, the hierarchical clustering also produces a dendrogram to visualize the data structure. How does K-means handle multi-dimensional data? Spaces that K-means can handle multi-dimensional because it calculates Euclidean distance in multi-dimensional space. However, feature scaling may be required to ensure all features contribute equally to the clustering process. Can K-means be used for supervised learning tasks? K-means is an unsupervised learning algorithm and is not directly used for supervised tasks like classification. However, it can be used as part of feature engineering or as a pre-processing step to help with tasks like semi-supervised learning. What is the impact of scaling features on K-means clustering? Feature scaling is important for K-means as it uses Euclidean distance. Features with larger ranges will dominate the clustering process. Standardizing features to have similar scales ensures that each feature contributes equally to the clustering. How do you handle imbalanced clusters in K-means clustering? Imbalanced clusters can be handled by adjusting the centroid update process or using techniques like weighted K-means. Alternatively, phase spaces that can using ensemble methods like K-means with small t can help address imbalance in the clusters. What are some techniques to improve the performance of K-means clustering? Techniques include using K-means plus to initialize centroids better, running the algorithm multiple times with different initializations and selecting the best result, applying mini-batch K-means for faster convergence on large datasets. What is the impact of the initial placement of centroids on the final clusters in K-means? The initial placement of centroids can significantly impact the final clustering results. Poor initialization may lead to slower convergence or suboptimal clusters. Using K-means plus for centroid initialization can help avoid this issue. How do you handle the issue of K-means getting stuck in local minima? To avoid getting stuck in local minima, you can run K-means multiple times with different initial centroid positions and select the clustering solution with the best objective function, lowest sum of squared errors.